Hi everyone, welcome back to my YouTube channel. So guys, we are back with another video in our 150 DSA question series. So today's problem is container with most water. So this is one of very important problem with interview perspective as well, right? It has been repeatedly asked in multiple companies interview. So make sure to be with me till the end of this video. And if you have already solved this problem, then a quick revision will definitely help. So you can do that as well. So yeah, before getting started, if you are new to this channel, then do consider subscribing my channel and you can follow me on other platforms as well. The link is there in the description itself. So let's get started with the problem statement now. The problem says you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma height I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container, right? So what has been given to us, let's understand with the help of an example. We have been given a height array containing, so it is containing the height of ith element, right? So there are n vertical lines such that two endpoints of the ith line are I comma 0 and I comma height I. So what we have to do is that we have to find out two lines that together with the x-axis form a container such that the container contains the most water. So we have to return the maximum amount of water. So two lines will be forming a container, right? So we have to return the maximum amount of water that the container can store. For example, here for this particular case, they have said that the maximum amount of water that could be stored is 49. So how they have determined the same? So here, if you will see, these are the two lines they have taken under consideration. One with the height 7, sorry, one with the height 8 and one with the height 7. Here you can see this is one is having the height 8 and one is having the height 7, right? Okay. So if one is of height 8 and one is of 7, if water you have to store, then what will be the level? This much only, na? Water will not overflow like this, right? So in the two lines, whatever would be the minimum line that we are going to consider, or sorry, I mean the minimum height line we are going to consider. So out of 7 and 8, which one is the minimum one? 7 is the minimum one. So we have got the height. Now we need the width as well. So how we are going to determine the width? So this is that distance, right? That distance between the two lines. So if you will see here, so 8 is on index 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 is on index 1 and 7 is on index 8. So 8 minus 1, 7. So we have got the width. Width is 7. Height we have already determined. It depends on the line which is having the minimum height out of the two. So 7 cross 7, 49. So that would be our answer. So here if you will see, so here we will get obviously 1 as the answer. Here the constant given, right? So now let's think about it. Let's think about it that what could be done, or the most basic approach that will come to your mind. If I'm asking you now, see, I have explained you the problem, so you could have understood that, okay, what would be the, see, our main target is to return the maximum amount of water a container can store, right? So the formula we already know to calculate, to determine the maximum amount of water, that depends on the height and the width. Height is going to be what? So two lines under consideration. So out of these two lines, whichever is the minimum one, so water level up to that only, na, minimum one level only. So that and the distance between the two lines. That's how. So one approach that you can think of is that what we can do, just consider all the possible pairs of line, consider them. For example, uh, as of now, I've chosen one. Now, one pair I'm going to make with everyone. One with 8, one with 6, one with 2, one with 5, one with 4, one with 8, one with 3, one with 7. Likewise, I have taken 8. So, 8 pair I'm going to make with every remaining line. So, 8 with 6, 8 with 6, 8 with 2, 8 with 5. So 8 with 5, let's say 8 and 5 as of now, if we have taken. So 8 and 5. So out of 8 and 5, which one is having the minimum height? 5, right? And if talking about the width, so 0, 1, 2, 3, 4. So 4 minus 1. 4 minus 1 is going to give us what? 3. So 15 would be the output, right? In case of 8 and 5, if you will check from here also, in case of 8 and 5, 8 and 5. So what would be our answer? Our answer would be 15, right? Because height we have determined and width we are determining by j minus I. So in that case, where we are considering the all the possible, possible lines, all the possible pair that could be formed. So what would be the sort of pseudocode kind of thing or a quick idea I'm talking about? So int I equal to 0, I less than n, where n is the height, right? And I will start from int j equal to I plus 1, j less than n, j plus plus, then area, just roughly I'm writing, okay? So it's not like the syntax and all. So area depends, like we want the maximum one, so how we'll be calculating the area? So that would be for width, so j minus I into we have to consider the minimum. So whatever is the minimum height of uh, I, from height of I, comma height of j. So likewise we will continue. So this is the first approach, or the brute force approach, that many of you must be think of. So area, what we want is that we want the maximum area to be here. So just I'm writing, so whatever the previous area has been calculated, so let it be there, and the current calculation. So the current calculation, whatever is maximum, just keep that in our area, right? So if you here you will see, so what would be the time complexities? That would be, yeah, because obviously we are just going till up till n, so roughly that would be big O of n square, right? So yeah, obviously when you're thinking it loud and you're coming up with a solution like that, that is fine. But again, interviewer would expect some sort of optimization and better approach than this one. So yeah, he is not going to be happy with this one approach only, right? So now, one thing to think in a greedy manner here is that at the end our main objective is to get the maximum amount of water a container can store, right? So it depends on two things, height and the width, right? So what if we maintain two pointers again, one at the starting index and one at the end index, right? Okay, and we calculated the area. Then comes that how we are going to, then comes this logic that how we are going to move these pointers. So if the height, let's say, if the current height, see, one I is on height I and one j, which is at the end of the index, that would be on height j, height I and height j. So now comes that which pointer to move. So if height of I is less than that of height of j, so which one, just think in a greedy manner, which pointer you are going to move? Obviously we are going to move I, because we will think in this way, okay, there could be a possibility that further if we will move ahead in this direction, in the right direction, we can get a particular element, a particular line with a greater height, because anyhow when you are moving, you are decreasing the width. So width you are already decreasing. So now what can contribute in increasing the area? Obviously height can contribute in increasing the area, right? So that is what this time our strategy is going to be to solve this particular problem, right? So that's what we have done. Again, this question comes in two pointer approach. So we have our the size of the array I and j pointer, where would be pointing at the starting index and j would be pointing at the last index. Then max area that we are going to return. So we will continue in this loop till the time I value is less than that of j. And again the same thing, max area anyhow is going to contain the maximum area. So whatever is the previous calculated area and our current calculation. So that would be j minus I into minimum height out of height I and height j we have to consider for determining the area, right? And now we are going to check that if the height I is less than that of height j, we are going to increment the value of I. Otherwise, we are going to decrement the value of j, right? And at the end, what we are going to do, at the end, we are going to return the maximum area, right? So now what you can do is, this is the homework for you, because I was also doing the same kind of thing, that you are just watching the video and you are just okay that I understood and just coding it up. So what I expect from you is that take this example and do a dry run with this approach. Do a dry run, try to understand okay how this is working, or if this is actually working or not, right? So do a dry run with the help of an take a copy pen, do a dry run, and then move to the implementation part once you have got the logic, right? So this is it from my end. Thank you so much for watching, everyone. I hope you are maintaining the consistency. I hope you are solving the problem daily. Thank you, everyone. Bye bye.